This conference will now be recorded.
Today, we are going to see with algorithms and how to analyze those algorithms. This is the topic which I am going to cover today. So let me share my screen. Okay. So today we are going to start with algorithms. Guys, this algorithm we are going to discuss irrespective of any language. It is not required that you should have some background knowledge on this program, that programming language. This is all about complete how to write a program and how to analyze it. Okay, what is algorithm? I guess you people might have came across this term called algorithm, data structure and algorithm. What is algorithm? Guys, come on. You can ping me in the chat box. What is algorithm? Well, algorithm doesn't have definite definition. Here, each and every people, they are given their own definition. Okay, it is not any fixed definition there. What is algorithm? Guys, come on, I want this session to be interactive. It should not be a monotalk. If at all data structure is going to be a monotalk, it will be very vague. It's a sequence of instruction. Okay, good, Nagaraj. Step by step approach to problem statement. Good. A set of statement. Good. Fine. So it's a step-by-step procedure to solve a problem. Simply, whenever I mean algorithm, I can say it is a step-by-step procedure to solve a problem. Okay. So who is responsible for algorithm? Why should I write this algorithm? Normally, whenever you're going for some development, which is nothing but I think so you people might have heard about SDLC life cycle. Have you learned about this one, guys? Software development life cycle. Have you came across this? Yes or no? Come on. No. Okay. Let me explain you. Whenever you people are going to develop some application, for example, right now we people are using WhatsApp. So whenever this application has came, they'll never directly go to the program. They'll never code the program. We are having certain procedure to develop a software. The particular procedure has been dealt by using software development lifecycle. Okay. So if at all some people is planning for constructing the home, they'll never construct the home as a whole. Once they buy the land, they'll never construct the home. They'll approach an engineer and they are supposed to have a blueprint, outer skeleton of a home. That is nothing but they'll have a design, right? The same way, whenever we people are going to write a program, we are not going to write program directly, we are going to design it. So this algorithm comes at the design phase. So there are two differences. The algorithm and program both are different. Both are not same. Algorithm and programs are different. Just for your information, let me give you overall information about this. Then we can go ahead with what is characters of algorithm and how to analyze this algorithm. Okay, speaking about this algorithm is the main thing which deals with design phase. Design phase in the sense, if at all you want some software to be developed, here I'll design by using algorithm. I'll write a procedure, I'll write a set of instruction in a human understandable way. Okay, that is nothing but algorithm. In case of program is nothing but implementing this algorithm as a logic. Implementation of this algorithm to a logic is called program. And for writing this particular algorithm, here I need the particular knowledge. Domain knowledge is required. Domain in the sense the particular knowledge about the requirement, whatever you're going to develop is required. So domain knowledge is required. And here, whenever you're going to program, certain programming knowledge is required. Clear? So I'm just speaking about what is this algorithm. Program is different, algorithm is different. Program is nothing but implementation of the logic. Design is nothing. This algorithm is nothing but designing it. Okay, so before you're going for some trip, what you'll do, you'll have a plan of it. So first we'll visit this particular place, then we can go for this place. We'll have a plan, right? The same way, algorithm is just a design, and program is implementation of it. Okay, for mainly writing algorithm, domain knowledge is sufficient, and for programming knowledge is required. Any programming knowledge is required. Okay, and here this algorithm is basically we are going to analyze the particular problem. We are going to analyze. We are not going to implement it. We are just analyzing. Okay, and here we are implementing and we are testing this particular whatever the logic we are analyzing. This is all about your algorithm, right? Theoretical explanation of algorithm. This is all about your algorithm. We are going to take a problem and we are going to have a we are going to have a step-by-step procedure how the particular problem can be solved. Okay, so this algorithm does not depends upon any programming language. Is a normal, common, human understandable way. I'm speaking about the characteristics of algorithm. Okay, whenever I say algorithm, I can write. Anyone can able to write algorithm, but it has certain characteristics. Characteristics in the sense where algorithm has to follow these rules during a during when you're writing the algorithm. So algorithm has main 5 characteristics. Wherever you go, you might have learned about this thing. Normally we'll have, whenever you're going to write a program, we'll have 3 process: input, process, output, right? So first characters of algorithm is input. Whatever the algorithm we are writing should accept minimum 0 or more input. So for a program, I can able to write a program even without input also. I guess you can able to give input by using range. Yesterday's program, I guess you people could remember. I mentioned range of 0 to 10. There I didn't give any input from the user. So there I'm accepting 0 input. If required, you can accept more inputs also. It's up to you. So whenever you are designing an algorithm should have minimum 0 or more inputs can be there. So this is the first characters of an algorithm. And next is speaking about your output, how your output should be. So whenever you're doing some task, it should be meaningful, right? Meaningful in the sense I'm giving some process, I'm giving some input. The data has to be processed and some output has to be returned back. So I should have minimum 1 or I can have more number of outputs. Clear? So whenever you are writing algorithm, the major 2 factors are input and output. If I'm pressing some key in my device, what happened? My system should respond. It should process and it should respond, right? So I'm giving input, it is getting processed, it is responding. That is my output. Okay, so if I'm clicking on the particular button, either one tab might be opening or multiple tabs might be opening, depending upon the condition what they apply. So that is your output. So algorithm without output is meaningless. So whenever you are writing an algorithm, I should have minimum 1 number of output or I can have maximum any number of output. And for a problem, I can write an algorithm. It can go like n number of steps. But what happened? It is not like a paragraph or it should not be too long. Like a essay, your algorithm should not be. Okay, your algorithm should not be a essay type. You should have definite number of steps. Definiteness and finiteness should be there. Definiteness and finiteness is important point in your algorithm. You should have definite number of steps and whatever the line you are writing should be effective, should be meaningful. Okay, effective in this is meaningful. Whatever the statements you are writing, I told you that algorithm is nothing but human understandable form. We people are writing, right? Should be effective. No unnecessary statements should not be given in your algorithms. And the last one is finiteness. These are the general characteristics of algorithm, guys. So whenever speaking about algorithm, this is the overall point you should keep in mind. Okay, and the theoretical part, how this is going to help us in program in this in our placement oriented point. Here, when you're speaking about like this way, here whenever we are writing a program, we people could come across certain issues. So whenever you're writing this a hacker rank question or hacker question, you might have some common errors. What are the errors? Guys, when you're writing hacker rank questions or hacker or some online question, you might have came across this error, right? time limit. Time limit constraint. So your test case, all your program is right, it will be executing fine according to the given input and given output, but you'll have timeout error. Okay, apart from those, you'll have runtime error, you might have compile time error. Then what else type of errors will be there? Runtime error, compile time error, then you people get, what else you people will be getting? Stack overflow. If at all you are using recursion, stack overflow error will be there whenever it is going infinitely. This is mainly for your recursion programs. Guys, don't worry about recursion. Many has asked about recursion. Where we'll be seeing about recursion either by end of the day or by tomorrow, we'll be seeing problems on recursion. So if at all you are using problems by using recursion is done, you'll be getting error like stack overflow error. Apart from this, you'll be having wrong input and output. Input output format error. Okay, and what else? Wrong answer. These are the common errors you people might have faced when you're writing some competitive exam. Okay, where your program will be right sometime, your program will be right and your answers also will be right. Whatever the questions they are given and whatever the answer they are expecting, everything will be right. But what happened, you'll be facing this error. More or less, they might have give 10 test cases or 5 test cases where one of your test case will be matching and the remaining test case will be failed. Based on the condition, any one of this condition might be wrong. Have you faced such errors? Yes or no? Come on, answer me. Yes. Okay. Okay, fine, good. So this is because you're supposed to concern about the algorithm. Whenever you're writing a program, you're supposed to concern with the factors of the algorithm. How much time the particular algorithm takes and how much space that the algorithm takes. So this particular stack overflow depends upon the space required for the algorithm. And this is time constraint. Apart from this, you'll be having compile time error in the sense if at all there is error in your logic error in your syntax errors are compile time errors. And speaking about a runtime errors, logical errors will come under runtime errors. Okay, let me write here separately for your understanding, guys. If at all time is exceeding, it is going beyond the time. For example, if we people are writing logic for prime numbers, okay, let us assume we are going to write logic for prime numbers. Can you people write logic for prime number? Guys, will you write logic for prime number? Just send me. Hardly it will take 4 or 5 lines of code. Just type it and send me. I'll show you what is the time complexity error you'll be facing. It can take hardly 2 to 3 minutes of time. Just for loop part alone, guys. Accepted number and for loop part alone. The 4 lines of code alone. I'll explain time complexity there. How does it depends on? So we people are speaking about how we are analyzing an algorithm. So right now we people are speaking about time complexity. Time complexity is the important factor which plays a major role in your programs. Whatever the program you are writing, time complexity plays a major role. and second thing will be space complexity. These are the two major things which we people are going to discuss about it. So in order to make you understand, just I given a task to write prime number logic. Come on soon. Okay. Nagaraj has sent. So what is the code you have sent? You're going to take a range from 2 to n and you're going to divide it prime number. Okay, not a prime. Okay, good. Okay, others. Okay, till n. Okay, less than n. I could see the code, guys, but I couldn't see the optimized code. So just let me copy paste here whatever you people are sent. So it will be time. Okay, let me. Optimized in the sense here I'm speaking about time complexity. Okay. Mainly I'm speaking about the factors of time complexity, how it is going to work. I got only two answers. What about others? One of a code I pasted. Okay, others soon. Just I'll explain you what is the complexity issue is there. Others? I guess everyone knows about prime number logic. Isn't it or not? Come on, answer me, guys. If at all you know, that's fine. If you don't know also, don't worry, I'll explain you. Respond me something. Everyone is so quiet. Are you people attending sessions by using mobile or laptop? How it is like? You know the logic. Okay. Okay, then I'll give you 2 more minutes. Okay, try it. Soon. What happened? Okay, shall we discuss here else? Okay, we'll discuss. Okay. Here, roughly, I'll take this logical part on. I'll not write from. We'll take a prime number. Okay, let it be. So normally we know that what is prime number. If I take a number 6, whether we'll say it is a prime number, how we are taking this number is a prime number, how many factors does this 6 has? So if at all a number has only 2 factors, I'll name as a prime number. Here, looking at this one, you could know that 6 has a factor 1, 2, 3. Again, 6 has a factor. So looking at the 7, 7 has 1 and 7 as a factor. These are two numbers, for example, I have taken. So prime number is nothing but the logic behind is checking factors for a number. If the number has only 2 factors, then the particular number is said to be a prime number. If the number has more than 2 factors, it is not a prime number. This is a common logic everyone knows. So how will you check the prime number logic? You start from, there are multiple ways for checking, guys. One logic is you can start from n and go to given number. If at all the particular number has 2 factor which is divided 2 times, so when I have divided and count is 2, we can say it is a prime number. This is one logic. Okay, the other logic is, you people, what you wrote, I'll take from 2, I'll go till less than number, which is nothing but I'll go to 2 till number minus 1. Okay, if it is not at all divided, which is nothing but 0 time it is divided, if it doesn't divide at all, then we'll name it as a prime number. This is one of the logic we are taken. Apart from this, can we take any other optimized logic? So what happens here is, if the given number is n, here in order to find the given number is n or not, how many times the loop should execute? The loop should execute n number of times, isn't it? If I want to check the given number is, if this number is a prime or not, this loop should execute n time to find the given number is prime or not. Here, in this condition, my loop should execute till n minus 2 times. Will you people agree this condition, guys? Yes or no? Answer me. Guys, are you getting the logic behind it? What I'm saying? Are you following me? Okay. Now this is the logic. Now we are going to see some more optimized way. So what are the optimized ways? So according to the logic what you people has written, for this logic it will take n iteration. N iteration in the sense n time your loop will be executed. So I say that this particular logic can be optimized further. So how we are going to optimize this? What I'm going to see, we people are going to see. If you take, I'll give you one more number. We'll take one more number. For example, if you take 10, what are the factors? 1, 2, 5, 10 will be the factor. If I take 100, what is the factor? 1, 2, 4, 5, 10, 20, 25, followed by 50, then 100 is going to be a factor, isn't it? So can you find some similarity between these three guys? Can you find some similarity between these three factors what are written? Not common values, some logical common similarities. Can you find something? Come on, answer me. Can you find it? It is very interesting. What is that? What is the similarity between these three? Finding factors, what is the similarity have you found?
Multiples of 2, ma'am.
Multiples of 2. Okay. Okay, any other common logic to optimize? Our logic, I'm speaking about optimization.
Ma'am, for even numbers, the digits are starting with 1, ma'am.
Okay. No. Can you find at the end? Common divisor, common factors. You people are seeing at the beginning common values. I'm speaking about the logic. Can you find the factors still? How many numbers we are having factor for a given number? If at all the given number is 100, I'll have factors only till 50. After this, the given number is going to be a factor, right? If it is 10, I'll have factors only till 5, which is nothing but 100 divided by 2. Here 10 divided by 2. Here 6 divided by 2. Since I have taken non-prime numbers, it will be easy for you to understand only by using non-prime numbers. This logic will be understood. For prime number, sum of 1 and the given number is going to be, it will not be clear for you. That's the reason I have taken these number as an example. Is it clear? So for whatever the number you're taking factors, you'll have only till the half of the number, then the given number will be the prime number. So now look at your logic here. What we did, we are taken from 2 to n minus 1. N minus 1 in the sense, if at all the given number is 100, we have taken a range from 2 to 99. Isn't it? We are taking a range from 2 to 99. What happened is, normally my loop will go only to 2 to 50. It will never go remaining for 40, nearly 49 step. It is going unnecessary time. It is iterating. Got the point what I'm saying, guys? 2 to 51 is going to go again from 50 to 99. It will go only unnecessary, even though the loop is iterating, the factors is not going to be there. The reason behind this, we are going to have only till half of the number. After 50, if you're iterating or not iterating is not all important. The reason is you're going to take a range only till number minus 1. So got this logic, what I'm saying? Come on. Guys, are you people there? So here, I'll go only to n by 2 iteration, n by 2 times. So the same logic what you people wrote, this logic goes n by time. So what I'll do is I'll make this n by 2 times here. This is nothing but integer division. So what happened, instead of going n times or n minus 2 times, how many times my loop executes here? Only n by 2 times. So half of my iteration has been reduced. So I have taken 100 for a better understanding. If at all 100 is given, here 99 times it executes here, here 98 times execute here, here only 50 times your loop is going to be executed. Actually, this should be number plus 1. The reason is the range will go till less than, right? So number plus 1. Till this, are you clear, guys? I'm going to optimize this particular logic still more. So before that, just let me confirm you people. Till this, are you clear? Come on, answer me. Are you people clear? Okay.
Clear.
Okay. And next is, I'll take this one where I'm going to still more optimize. Instead of going 50 times, here I've taken 100 as an example, right? Instead of going 50 times, just by executing 10 times, I'm going to find whether the particular number is a prime number or not. I'll tell you the logic behind it. The same program, what you write, you're going to see how to optimize this one. So this is the factors of 100. If you take 100, this is a factor. So what I'll do is I'll never go till 100. I'll go only till 10. So just a minute. I'll write here 1, 2, 4. Give me a second, guys. Just let me write here 5 and 10. And the given number is 100. So you can notice that by using the first half factor, I can able to generate the next half factor in it. Whatever the number it may be, For our convenient, I have taken 100, guys. Just for by using 100, I explain you. You can apply this logic for any number. Okay. So what I'll do is I'll take first half of the number, which is nothing but I'll go only till square root of the given number. I'll go only till square root of the given number, and I'm going to check whether the given number is a prime number or not. The reason behind is, if at all, if I know the first half, by using this half, I can able to generate the next half. I'll let you know how we are going to generate it. So I'm going to divide it as a 2. This is a part 1 and this is part 2. In part 2, what we can do is I'll take this value 100. 100 divide by the particular value gives you 100 again. So by using 1, what we are generated? We are generated 100. Again, by using 2. 100 divide by 2. It gives you 50. Clear? Again, 100 divide by 4. It gives you 25. 100 divide by 5. It gives you, did you miss anything? 20, right? Sorry guys, sorry. 100 divide by 25, I'm right, sorry, 20. Sorry guys, small confusion. Okay. And 100 divide by 100, which gives you 10. So by using one half, I can able to generate the other half. That's possible. So we people might have a doubt. I have this half right now. Can we generate the other half? Yes, that's possible. So I'll show you how to generate this half. If I know this half, it is possible for me to generate the other half. So 100 divided by 100, it gives you 1. 50 something will do, just a minute, gives you some calculation. 100 divided by 100, 1. Just a minute guys, some calculation part I missed it. 100 divided by 50, sorry, 100 divided by this value 50 gives you 2 again. 100 divided by 25 gives you 4 again. So if you know one half, the other half can be generated. This is the logic behind prime numbers. Guys, got it what I'm saying? Guys, clear with it? Clear with this logic what I'm going to implement here? Okay, fine. Now I'm going to write logic. Okay. Now let me write a logic here. I told you you're going to go till only square root of the given number time, right? So instead of this, what I'm going to do is I'm going to make square root of this given number. Square root of given number, and this square root of the number, what I'm going to do is I'm going to convert as an integer type. Is this clear? Come on, clear with it. The same logic guys, previously I mentioned n, they are optimized by n by 2 times. Again, I have modified as square root of time. So what happened here, the number of iteration is taken as 1/4 of the time. 1/4 of the time is reduced. So your logic, what you have written is n time. Here, 1/4 time your execution time has been reduced. Clear how to optimize the program? Guys, answer me. You people are so quiet. What happened?
Ma'am, once repeat, ma'am.
Which logic? The last one alone?
No, ma'am.
The entire logic you want me to repeat?
Yes, ma'am.
Okay. Guys, normally whenever you are writing prime number, initially what we did is you have written n times. N times in the sense you have written the condition here. Instead of this, what you people has mentioned is you have mentioned your number. Here I'm doing square root. That's the reason I'm mentioning into there, Nagaraj. That's the reason. I'll explain you. So what happened is I'm passing a number. Normally we are going to check a prime number. General factor is I'll check up, not to check a prime number. Normally you can able to go from 1 to given number. So 1 to given number, if the number is divisible 2 times. So finding factors is the, how many factors the number has is the prime number logic. Normally if I take 7, 7 will have 2 factors, which is a prime number will have only 2 factors. So it will be divisible only by 2 times. So if it is divisible 2 times, I can name it as a prime number. So here what we did is we are taking from a range of 2 to n minus 1. So if I take, if it is a prime number, if I take 1 to given number, 2 times will be divided. If I take a range from 2 to, if I take a range from 2 to, for, let us take 7. For 7, if I take a range from 2 to 6, where the number will be divided, it should not be divided. The reason is I didn't include 1 and the given number. For 7, I've taken a range from 2 to 6. I didn't include the given number and 1. So the number should not be divided. So this is the logic we are written here. I'm taking a range from 2 to given number minus 1. For sure, if at all you're giving number, it will take n minus 1. If you are taking range like this, the number within this range should not be divided. If at all the particular number is divided within this particular range, I'll say it is not a prime number. I can come out of the loop immediately. Okay, throughout the program, if the value is not divided, then I can able to write. Okay, then I can able to write this particular number as a prime number. This is the logic which we have written here. So here we people are going to speak about how many times this loop is executed. If at all you are taking a range from 2 to n, you can notice that n minus 2 time your loop is going to execute. You are going to optimize this one just by mentioning n by 2 times. Instead of going n time, what you are going to do is you are going to iterate n by 2 times, n by 2 plus 1. The reason is, instead of, if I know that if I'm finding a factors for a given number, for any number, I'll have only half of the number as a factor. Then the given number is going to be a factor. Somehow we are going to take a range only between 2 to n minus 1. So I could optimize this one, such mentioning such a way, not going till given number or given number minus 1. Instead of this, I'll go only till half of the iteration. So whatever the prime number I'm going to check, I'll go only till half. It is not necessary for me to go till end of till the given number. The reason is I'm not going to take a range between 1 and, if we take 100, I'm not going to take a number 1 and 100. I'm going to take range only between 2 to 99. So I'll take a value from 2 till the number divided by 2. The reason behind is any number will have a factor only till half of the number factor will be there. You can check with any number. The number will have only half of the factor. After this, the given number will be the factor. Okay. So that is the reason you can implement this method. So if at all you're implementing this method, you can notice that is going only till half of the number. Here n times, n minus 2 times, n by 2 times. And this also can be reduced till more, which is nothing but executing till square root of the given number times. If at all I'm going to square root of a given number time, that is sufficient. The reason behind it, if you find first half of the factors, the multiples of this will be the next half. Okay, multiples of this is going to be next half. This is what I told you. The first half are written here. So by using this, I'm going to generate the next half. The given number is 100. So 100 divided by the first generated number will give you the last number 100 again. So 100 divided by 2 is going to give you the next number 50. 100 divided by 4 is going to give you the next number 25. 100 divided by 5 is going to give you the next number 20. 100 divided by 10 is going to give you 10 again. So if you know the first half, the multiples of this will be the next half. So if the number is divided by the first half, for sure the number will be divided with the next half. So it is sufficient for us to go to square root of the given number time. So if you want to find square root, I'll mention here as square root of given number. And if I'm taking square root, this particular number will become as a float value. It will become as a fractional value. So I want as an integer value. Only in case of C program, it will convert automatically, guys. Here in Python, you're supposed to typecast it. Then you're supposed to increment the value to it. Is this logic clear?
Ma'am,
Yes.
for a prime number, the only two factors will be, no, ma'am.
Yes, two factors will be there.
Then if the loop is iterated for more than two number of times, then we can break it and print as
Here I didn't include the two factors also. We are taking a range only from 2 to the number less than the number. We didn't include the range. When whatever the number we are giving, we are excluding the one and the given number here. You can look at the range here.
no, ma'am, for optimizing the code, we can iterate for only two times, no, ma'am. If it is occurring for a third time, it will print as not a prime number.
Give
Then we
some
have
number. Which number you are saying about? Give some number.
take a number 7, ma'am.
Okay.
It is a prime number, no.
Okay, 7 is the prime number. Yes.
It will calculate the factors. If
Okay.
it has,
What is
if it has
square root of 7? Guys, what could be the square root of 7? 2.66, right? 2.64.
Yes, 2.6.
Okay. 2.64. Let us assume you are taking square root of 7. 2.64 is you're getting. So till 2 it will be executed. 2, 2, 2. The number is 7. Modulo by 2. No. The condition is false. There is no more iteration. So it will display it's a prime number. This else part is for your for loop, not for if condition. You're not clear? So this will execute 2, 2, 3. 2 to 3 in the sense it will go only to less than 3. Is this range clear? Guys, as per your condition, I'm speaking, guys, square root of this particular 7. Come on, answer me. Square root of 7. We are taking this number as you say.
Ma'am,
I'll have
I am saying for every number, ma'am.
For all the number, it will be working. You can take this logic and work it and see. You can have manual calculation as such.
For every number, we should take the range as up to 3 only, ma'am. If it iterate for third time, then we should print the not a prime number. The given number is not prime.
What is the 3 fixed condition here? You're saying 3 times in the sense, what is the 3?
Number of factors, ma'am. Number of factors, ma'am. If it has only 2 factors, it will be prime.
Okay.
If it
Your
has
question is
more
not
than,
clear. Just
if
a
it
minute.
has,
Just a minute. I couldn't get your question. Guys, can you explain if at all you're getting? What you're asking, you should have only 3 factors.
for optimizing, ma'am. For optimizing the code, I am saying.
Okay, how will you optimize 3 times alone?
The loop should iterate for only 3 times.
What's the condition for it?
Factors condition, ma'am. Num divided by I equals to 0.
This is the logic you're writing here. Can you show me the, have you written or you're asking me?
I am asking for you, ma'am.
That is not possible. You can't able to scrutinize that only by 3 execution I should find the prime number. This is a more efficient way. Apart from this, I couldn't hear any efficient way. But this is the maximum optimization can be done. Only 3 times we can't able to do it.
Why, ma'am? Any reason behind it?
No one has found it. This is the most efficient logic so far they have found. So if you are finding, just let me know.
Okay, ma'am.
Okay, this is the maximum possible. Possibility in the sense it will be whatever the logic you are finding should work for all the numbers, not only for this number, it should work for all the numbers. So whatever the logic I have given you, it will work for all the numbers. This logic. Is it clear?
Clear, ma'am.
Okay. Guys, you can notice that the same prime number you wrote, the same program I wrote. I didn't write anything different at all. The same program, just I modify only one statement in it, which gives you the huge difference. This is how the time complexity plays a major role. How many times your loop is executed. For each and every execution, it takes certain number of time. Okay, here this time is calculated by using time function. Guys, just for sample, I have given this factorial, this one, prime number program like this, lot of programs are there. So whenever you're writing logic in your competitive exam, have a habit of writing such a way optimized question. So optimized answer. Don't write as a general one where everyone write, which makes your program unique. You should show your program as a unique. The same prime number program will be written by everyone. Show some uniqueness in your code, which will impress the panel members. Okay, so this time is calculated by using time function and space is calculated by using space function. So whenever you are writing program, you people are supposed to be concerned with these two factors. One is time and other is space complexity. Apart from those few factors are there, which I am not going to discuss about. So we people are not responsible for those things. That is nothing but network plays a major role, and apart from this, your power consumption, how much power is required for executing the particular application, and followed by CPU register. All those things are required. And right now, we people are going to discuss about time complexity and space complexity alone. How to calculate the time complexity and space complexity. A small example which you have seen how time complexity plays a major role here. Here the same program, whatever you have written like this will be done. The same thing might have done in some online exam also. So what happens here is you people could find that you will be getting timeout error. The reason behind it, you people might be wondering the same answer I'm getting. Why don't it pass through the test case? This is the reason behind it. So what happened if the given number is 1000 or 10,000? What happened? The loop has to execute 10,000 times. If at all the given number is n, if you're iterating till n, if you are using this first this logic, if they're given as 10 power of 5 or 10 power of 6 times, so it has to be executed those many times, right? It has to execute those many times. What happened? Your loop will go with it will go keep on executing. For smaller number, you will not find the huge difference. For huger number, whenever your number is larger, you can able to find out the difference there. Okay, so here this is the best optimized method for your prime number, guys. So far, this is the one. This is a efficient way. Apart from this, I don't guess that no more efficient way is there. And now we are going to see how to analyze the time. So as I told you that this time analysis is done by using time function. We are going to do by using time function, and this particular space analysis is going to be done by using space function. So let me write a small algorithm for you people. A common algorithm. Let me take an algorithm for swapping of two numbers. We are going to have a time analysis, how to analyze the time. And you people might have came across writing big O notations, all those things, right? Big O notation, O of n, O of 1, log n, all those things. This is what your people are going to discuss right now. How to write these statements. Okay, now let me write a small algorithm. Here I didn't mention any language, guys. Just in order to mention this is the algorithm, let me write algorithm, and here we are going to mention swapping of two numbers. Swapping of A and B we are going to write, and here let me write temp assign A. Since it's an algorithm, generally swapping, it's normal swapping. A assign B and B assign temp. Okay, now we are going to calculate time complexity for it. So let us assume how to calculate time. Here time complexity in the sense I didn't mean about this watch time, guys. We are not going to speak about watch time at all. Here we are going to speak about how much unit of time required for each and every line. Okay, generally we can consider that for each and every line it takes 1 unit of time. For each and every line, when it is a normal line, it is not a looping process, then it will take 1 unit of time. Okay, so let us assume this line takes 1 unit of time, and the next line, this takes 1 unit of time, and this takes 1 unit of time. So overall, how many unit of time is required for calculating this particular, for executing this particular algorithm? It requires 3 unit of time, which is nothing but your time is calculated by using f of n. Assume 3 unit of time. This 3 is a constant value. Clear with it? This 3 is a constant value. So whenever it is a constant, I'll give O of 1 as a notation, order of 1. I'll tell you how to calculate this big O, theta, and followed by this omega function. I'll let you know, guys. Just know it. Whenever it is a sequential program, each and every line requires 1 unit of time. Overall, 3 unit of time is required. So 3 is a constant value. So whenever it's a constant value, I'll write as O of 1. So it might be 3 or it might be 300 or 3000. Whatever the unit might be, whenever it is a constant value, I'm supposed to write only as O of 1. That constant value is given with the notation O of 1. Till this, are you clear? Come on. Guys, this time complexity and space complexity calculation is very much important. Is this clear, guys? A small statement are written. I have told you how to calculate this time complexity. Yeah, I guess it is recording. Yeah, it is recording. Okay, shall we go for space complexity? Okay. And next is we are going to speak about space complexity. So let me write space complexity this side, guys. Okay. Here I'm going to write space complexity. Here for each and every line, as you say that, where for space, how many tentatively let us take here, where A acquires one unit of space, and here B acquire 1 unit of space, and let us assume here temp acquire 1 unit of space. So overall, how many unit of space is required? Again, 3 unit of space. Something is. So again 3 unit of space, where your space complexity is 3 and this 3 is also a constant. So both the space complexity and time complexity is given with the notation of O of 1. Clear with it? Guys, are you clear with the basic function how to calculate time complexity? Now we'll go ahead with looping. Just give me confirmation till this, are the people clear? Come on. Okay. Now we'll see to how to calculate this time complexity by using looping. If at all looping is there, I'll teach you people how to calculate this time complexity. So let me write a for loop. Let me write a general for loop as you write in C programming. Here If at all you want, you can mention range also. If at all you're considering for certain programming language, consider according to the programming language. I like generally as a common for loop. For I assign 0, I less than n, and followed by I plus plus. If this is a for loop given. How to calculate the complexity of it? Okay. So we people know that this particular loop will execute how many times? How many times this loop will be executed? N times or n plus 1 time when the loop breaks? How many times the loop executes my here? N times or n plus 1 times? When does the loop breaks here? Your I value start with 0. Whenever your I value becomes greater than n, your loop breaks, which is nothing but whenever I'm going to n plus 1 time your loop breaks, right? So this is the number of iteration. Right now we are calculating about time complexity, guys. This executes n plus 1 times, and here this statements, it might be of any number of statement, and this statement will execute n times. Okay, it will execute n times. So overall, if at all you are calculating, so we are not supposed to bother about this one. Don't worry about this one, guys. We are going to look only the number of statements, how many times it is executed. So when you are calculating this one, you can notice that if it is bold, it is easy to write. Here, notepad each and every time I'm supposed to type, guys. Just a minute. Give me a second. So here, I'll be executing how many times? N times this loop is executed. Don't bother about this. We are supposed to concern only with the number of times this loop is executed. Okay, number of times this loop is executed. We are supposed to consider only about this one. Just given this one only for your information. This is not required. So calculate this alone right now. So n times will be executed. So n is mentioned with the notation f for order of n. So this function is executed. Let me write here, guys. This function is executed n times. So it is given with the notation order of big O of n. So your order is not supposed to consider a degree of polynomial. We are going to consider it. Let me give you one more. I'll give many examples to calculate, guys. Don't be worried. Okay. If the same program, I'm going to write in some different manner. Let us execute. Let us assume I'm going to start from n and I'm going to go till greater than 0. And I'm going to decrement each step. Now, how many times this loop the statement inside this for loop is going to be executed? 0 to n or n to 1. 1 to 10 or 10 to 1. Both are same, right? Again, this is going to execute n times. So the order of this execution is going to be order of n. Guys, is this clear? Are people following me? How to calculate this time complexity? Guys, just we are supposed to see how many times this statement is executed. This statement executed n times, so calculated. So n times is function. Your time is given as n, so it is given as order of n. Come on, response to me. Guys, if at all you're not clear, let me know then and there. Don't be quiet. Do you have any doubt? Shall I proceed to the other example? Okay, I'll explain once more. Okay, you want me to explain once more? So here we are going to calculate time complexity, ma. In order to calculate time complexity, I have taken example of looping. Normally we'll be writing program only by looping, right? So how to calculate time complexity for the looped program? Here in case of looping program, look at this for loop. When this for loop terminates, once your I value is greater than your n value, it will terminate. So this I loop will execute n plus 1 times. Okay. And the statement inside the for loop, how much time it executes? It executes n times. When it is coming with I plus 1, which is nothing but whenever your I value is equals to n value, it will be breaking, right? Whenever I value is equals to n value, it will break. So how many times it will execute? So once it goes till n plus 1 time, it will break. So this particular statement inside this will execute only n time. So we are going to calculate the time complexity required for this loop. How many times the statement inside the loop is going to be executed? The statements inside the loop will execute. We are supposed to consider only the degree. Normally we'll say order of expression, degree of expression. We are supposed to consider only the degree of this particular loop. Here degree of the loop is n time the loop is executed. So I can mention the time required is n. The time complexity is considered as n. So n has been written by using order of n. I'll tell you guys how to convert this function to order of n in the forthcoming session. Initially, if I say directly what is asymptotic notation, you people will be confused a lot. Okay, just first let us find the time complexity of it. Then we can able to see how to see the asymptotic notation. The same expression here I have given as I'm starting with n, I'm going till 0. Here what I did, I started with 0 to n and here n to 0. The same step, right? Going from first step to 10 step, 10 step to first step. However, you're supposed to climb 10 steps there. So what happened? How many times your loop is going to be executed? N times your loop is going to be executed. Again, the time complexity for us is n. Is this clear? Clear with it? Okay. And next is, guys, I'm going to give few examples how to calculate it. Okay. So if you see some loop or something, there you can able to calculate by your own. Okay. Now let us take some other example. Let me take again this for loop. Instead of typing, okay, let us assume I'll take I and I'm going to go to less than n. Let us assume instead of incrementing 1 by 1, I'm going to have incremental step by 2 to 2. Normally here I'm having going from 0 to n and I'm going incrementing 1 step. Here instead of this I'm going to go 2 step. So how many times this particular loop will be executed? N by 2 times. Guys, can you understand this one? If I'm going till n plus 2, I plus 2, what happens? The statement inside the loop will execute 2 times, right? If the n value is 100, this loop will execute 50 times. Isn't it or not? Yes, right? Okay. So what happened? Here your function is written as f of n assign n by 2. Here we people are supposed to consider only the value apart from your constant value. Your constant value is 2, just omit it. So you're supposed to take only 1 here. So again, this expression is going to give you only as big O of n notation. So whenever you're writing, you people are supposed to omit the constant value, whatever there is an expression. Okay, where degree of polynomial here is only n. Here, if in mathematical term, you people might have came across degree of polynomial. Here, degree of polynomial for this expression is n. So the expression is written here is n by 2. So no matter that your I value is incremented by 2 or your I value is incremented by 10 or your I value is incremented by 20, whatever it is, your order of n is, your order will be only order of n. Is that clear? Either you're mentioning with each and every step with 1 by 1 step, or you're going to increment each and every step by 2 step or 20 step. It is not all a matter. It is going to, you're going to have a order of polynomial. You're going to have a notation as order of n as your notation. Clear with it? Shall we go for nested loop, single loop? Are you people clear, guys? So this is incrementing 1 step and this is decrementing the same iteration. You're getting order of n. I'm trying to increment 2 step. Again, I'll get order of n only. Okay. And next is we'll see how to calculate time complexity for the nested loops. If at all the loop is nested one by one. So let me write one more structure, guys, here. Guys, this concept calculation is very much important. If at all you find something difficult, let me know immediately. Never hesitate. I'm ready to repeat again also, don't worry. This calculating time complexity, space complexity, everyone face difficult, but this is very simple concept, guys. This is statement inside this one. Okay, let us assume there is a nested loop like this. Now, how can I calculate the time complexity? We people might have a question. How to calculate now? If it is a single loop, I'll calculate directly, that is fine. Now, how could I calculate it? Now, let us assume for this loop, how many times this loop will be executed? Normally, we know that the outer loop will execute n plus 1 time. The reason is I'm starting from 0 till n. So once it reaches the n value, it's going to break. So n plus 1 time the outer loop is going to execute. And followed by your inner loop. How many times this inner loop is going to execute? This inner loop is also going to execute n plus 1 time. But what happened? This loop along with this loop is going to execute, right? So those n into n plus 1 time. Will you agree this one, guys? This J loop will execute n into n plus 1 time. This n is nothing but your I loop times your J loop along with that n plus 1 time. The property of J loop is n plus 1 time along with this I loop. So n into n plus 1 time your J loop is going to be executed. Okay. So overall, how many times this loop as a resultant, how many this degree will be executed? How many times this will be executed? So overall, if you multiply this one, how many times is going to be executed? It is going to be executed n square times. N into n times this loop is going to be executed. Is it clear? This loop will be executed n into n times. So overall, you'll be getting order of n square as your it will execute. It's very hard to type, guys. It executes order of n square. Is it clear? Guys, we are supposed to consider only this one. The degree we are supposed to consider. Omit all the things. Consider degree alone. So for calculating degree, we people know what is the order of it. So I'm calculating I value executes n plus 1 time and a J loop executes n into n plus 1 time. Normally this loop is for n plus. So n into n plus 1. And looking at the statement, how much time is executed? It will be executed n into n times. So your order will be n square time it is going to be executed. Okay. Now, we people might have a doubt. If at all we are having some conditions like this. So let me write the for loop here. Here let me modify it as j less than I. And let us have some statement inside this. Okay. Now, for this, how should I calculate it? How does he know? Here, I know that this outer loop will calculate n times. For this loop, it depends upon I. If I'm getting scenario like this, how to calculate the time complexity? Okay. Just we are seeing how to analyze each and every algorithm, guys. It can be of any number of statements inside this. Just we are going to see how many times it is going to iterate. Okay. Now, let us calculate the complexity here. What you're writing is okay, you're answering this one. If I increment by 2, we are going one little half of the number, then how this value is considered. Here, when you are considering this particular degree of polynomial, In case of degree of polynomial, here f of n is mentioned such a way, right? So whenever you're writing degree, we'll name it as a degree of polynomial, guys. Yeah. I guess you people might have came across in schoolings or in colleges, you might have came in mathematical subject, you might have came across this one, degree of polynomial. Degree of polynomial will omit all the constant value what we are having, as we did here. Could you remember here? We got order of 1. We got 3, but what we did? We omitted the constant what we got. I have mentioned only 1. The same way, here whenever we get some constant value, we'll omit the constant value, we'll take only the whatever the order we got. So the constant value will be omitted. So the degree of polynomial is taken as n. Is this clear?
Ma'am, then it will be calculated wrong time, no ma'am.
No, the same order is going to give you only the same order. It's not a wrong
But the
time.
loop, it is repeating only n by 2 times, no ma'am. What is the difference between upper loop and
Here,
down?
the time in the sense we are not going to speak
Time?
about the clock time. There is a time time calculation according to the analysis time. We never speak about the clock time here. So whatever this program I told you, this normally for our understanding I told you guys, this one we are not speaking about the clock time. This is not a clock time. This is nothing but we are speaking about the time function. I guess you people could remember. Here I told you, right? Time is calculated by using time function. We are seeing how to analyze this time function.
For every loop, the time will be constant, ma'am.
Not for every loop. It varies. This is what I'm saying. If the loop is going to go from 0 to n or n to 0, you will have n as a degree of your polynomial.
That's not, ma'am.
Okay.
Order of
If
n. Order of
order
n.
of n. Order of n is you're going to have. If at all you're going to increment by 2 or increment by 20, whatever it is going to have n by 2. If you're going to increment by 20, you're going to have n by 20 as your value, right? So we are not supposed to consider this constant value in a degree of polynomial. So we'll have only order of n. This is how we'll calculate. We'll never consider constant value in a calculation. So not only now, after this also, whatever the calculation you're having, you'll never consider the constant value. Clear? The constant value in the sense 10, 20, 1, 2, 3, nothing will be considered. Only the value will be considered here.
Ma'am, what the n by 2 value, n by 20 value indicates, ma'am? What the order of n indicates?
Here order of n is n time the loop. Here the mention is time complexity for this is order of n. This is the notation which is mentioned. If at all
What
you
does
are
it
calculating,
represent? What it represent, ma'am?
here this is nothing but how many times your loop executes.
Then order of n, O of n, what it represent, ma'am?
This is a notation which is the asynchronic notation. This is a symbolic notation for mentioning your time complexity and space complexity. We'll see about asynchronic notation, how to do it. After seeing this example, I'll teach you people how to see asynchronic notation.
Okay, ma'am.
Okay, so there we'll be seeing big O, omega, theta, all those things. Clear?
Clear, ma'am.
Okay. Okay. Now, if this is your for loop, how can I calculate the time complexity for it? So normally, let us trace this program I, j, and we'll have number of times. So whenever your I value is 0, your j value will come inside, your j value will be 0 and it will execute how many times? 0 times. So no iteration will be happening for the first time. And for your second time, just I'm tracing this loop, guys, okay? And for your second times, your I value become 1 and your j value will be executes 0. So 0 executes one time and your j value will become as 1. So it terminates. The condition fails, it terminates. And for a next iteration, you can notice that your I value becomes 2. So it executes 0. One time is executed. Again, it goes to 1. Again, one time it is executed. It goes to 2. Your loop breaks. So from this, I can able to come to the conclusion. Whenever it is 0, it goes 0 times. One when I value is 1, 1 times. When I value is 2, 2 times. So how many times this loop goes? This loop, if your I value goes n times, this loop goes such a manner, just a minute. If I value goes n times, it will go like this, right? First when I value is 1, yeah, sure, I share the notes, ma. I just let me save to it. I didn't save it yet. I will save to it immediately. System is going to other folder. Okay. So what happened? Yeah, if this goes 1 plus 1 time, 2 times, 3 times, it goes like this, right? So till your n value it goes. Guys, can you able to trace this one? Just a normal tracing of this particular program. When I value is 0, J executes 0 time. When I value is 1, J executes 1 time. When I value is 2, J executes 2 times. So how many times it goes? When I value is n, J executes n times. So what is this formula? This formula we people might have came across, that is nothing but n into n plus 1 divided by 2, which is nothing but natural numbers, right? N into n plus 1. These are the natural numbers till n value is going to go, which can be given with the notation n into n plus 1 by 2, which is nothing but here time complexity. A function of time has been calculated with the formula for this particular program n into n plus 1 by 2. So expanding this one, which can be written as n square plus n by 2. So the highest degree of polynomial here is taken, highest degree is taken as n square. Guys, just learn how to take the polynomial, how to take the degree of polynomial. Here the highest degree is taken, your highest degree is n square. So it is written with the notation of big O of n square, not n square. Guys, this should be a square. So let me write cap symbol here. This is not n2, this is n square. Is this clear? Can I move for the next one? Do you have any doubt on it? Just if the program is like this, you can trace it, you'll be getting certain logic behind it. So you can able to convert this logic as a formula. Sum of natural numbers expanded. Once you are expanding, what happen? I'll remove the constant value. After this, if I'm doing like this, what happen? I'll get n square plus n by 2, where it's higher degree of polynomial, which is nothing but n square is given with the notation of order of n square. This is how I can able to calculate it. If they are given with some other scenario, for example, guys, all the scenario you people should be aware of it, guys. That's the reason I'm giving multiple example for calculation. Okay, whatever the scenario they are giving, you should be in a position to calculate it. To the maximum, all the combination I'll give you people, guys. Okay, don't worry, I'll give you all the combination how to calculate this one. Let me take some other scenario. What I can give, P assign 0, and let me have a for loop. For I assigned 1 and I less than or equals to P and followed by I plus plus. There is a loop. And here, let us assume I'm going to increment my loop P plus I. So we'll see how to trace this one and find out. The reason is here, the previous condition what we mentioned, this I is going to execute n time. Here, this I is going to execute P time. This P might be of any value, and moreover, I'm doing some manipulation with this P. So I'm not sure that this P will this particular P will reach at certain number, whether n times it will execute. Before that also you can able to do it. For example, when you're calculating Fibonacci series or something, I can able to generate the particular number even before going to the particular range. So I'm not sure about within how many iteration this particular condition will be satisfied. Let us trace this one and I can able to find out the notation of it. What is the time function for this particular loop? So let me mention your I and P. We'll trace it. So whenever your I value is 1, I'll come inside where your P becomes, the initial value of P is 0, so 0 plus 1. So when your I value is 2, okay, already it is 1, so 1 plus 2. So when your I value is 3, your P value will be 1 plus 2 will be already there, along with the 3 will be there. Okay, just look at the loop here, what I've mentioned here. Again, your I value is 4, your P value will be 1 plus 2 plus 3 will be there along with that 4. And so on, like this it goes. So when your I value is K, I doesn't mention N here. The reason is I'm not sure that it will go to N iteration. Before that also it can be terminated. So let me give, if your I value is K, how many times this value will be executed? 1 plus 2 plus 3 plus 4 plus it can go till K time. Right, here this is nothing but V does not mention N. Reason is I doesn't know only these many times this loop goes. Before that also you can, your I value your P value might be, condition might be satisfied. So that is the reason I have mentioned as K value here. So when does this loop breaks? When does this loop breaks? If at all, what is the condition I have mentioned here? Guys, just let a minute, here this condition I mentioned wrong, guys. It should be some N value. Okay, not I. Sorry guys, just type during typing I made small mistake. Here I mentioned P less than or equals to N. Just a minute. Okay. Here this particular, guys, listen carefully, a small modification I made here. This I'm going to do some manipulation with P. So I'm not sure that when your P will reaches N. It might reaches, it is not necessary for me to go till N times. I can able to go, I'll reach my N value even before N iteration also. So when your loop will execute, when your loop will terminate, let us assume when our loop will terminate, whenever your P value is greater than N, our loop is going to be terminated. So according to this given calculation, what I can do, the same formula, I guess you people could remember. Here, till 1 to N we are going, here 1 to K. So what could be the formula here? We are supposed to substitute K into K plus 1 by 2. The normal, the PP, what are the formula we knows. So what you are going to calculate is we are going to calculate the N value here. So how we are going to calculate f of N value? N value is calculated with the formula K into K plus 1 by 2. So now let us evaluate this one. So once you are evaluating this one, what happen? You will be getting K square plus K by 2. So once you are mentioning this one, it will come here as N assign K square. N assign K square, and where this K square can be, where we need the value of N, right? So we can able to assign that where K is equal to square root of N. Guys, is this clear? Just when this condition fails, when the P value is greater than N, whenever your P value is greater than the N, this loop breaks. Right now, we people are in a position to find out what is our time complexity here. So I'm writing a condition. We know that the P value calculated here is this is a calculation which is the sum of natural numbers. So let me write N assign K into K plus 1 by 2. So when I'm evaluating this expression, I'll get this value, and I'm taking the higher degree of polynomial, I'll get k square. For k square, if I want to find the n value, what I'll do, I should bring my 2 here. So a k value calculated is square root of n. So square root of n is your order of. So here f of n mentioned here is order of n square. Sorry, ma, order of square root of n. I'm saying something else, sorry. Guys, is this clear? Just let me know. A small calculation part we did here. Come on, answer me. Is that clear? Are the people there? Everyone is so quiet. Is that difficult to calculate? Okay, I'll repeat once again. Okay. Guys, it's very simple. I'll repeat just a minute. Listen carefully. This is your scenario I have given. Here for this, we are going to calculate the time complexity. Here we know that this particular loop is going to execute n times. But what I'm doing is I'm making use of p and I'm going to do some manipulation. So I'm sure that this loop is not going to execute n times. This is going to execute less than n times. Okay, this is going to execute less than n times. So when it is going to execute less than n times, I should find the complexity of it. So let us write a rough calculation. Whenever your I value is 1, your p value will be 0 plus 1. Whenever your I value is 2, 0 plus 2. Whenever your I value is 3, so here this value is added along with the existing p value. So for the first calculation, 0 plus 1. For the second calculation, 1 along with I, so 1 plus 2. For the third one, I value is 3, so 1, 2 along with the 3 will be added. And for the next calculation, 4, so 1, 2, 3 along with that 4 will be added. In this manner, the value will be keep on added. So if it is going to k iteration, I'll never give a value as n. The reason behind is we are not sure that it will go to n. Before n itself, this particular loop might be terminated. So let us assume the position as k, and if it are k, what happen? It will be going to k iteration. This is nothing but the formula what we have seen, sum of natural numbers. Since I have mentioned k, I can mention k into k plus 1 by 2 as my expression. Now we know that this loop will be break when your p value is greater than your n value. Until your p value less than or equals to n value, it will be executed. Once it is greater, your loop is going to break it. Okay. Now we are supposed to calculate this logic here. Till this we are seen, and now we people are supposed to calculate here n value. For calculating n value, what I'll mention, we'll mention here is, normally you people might have a doubt why I have mentioned this one. Let me mention here. This is your p value, right? This is your calculated p value those many times. So your p value greater than n value. This is the expression. The same expression let me write here. Greater than n value. Here instead of greater than n, let me assume equals to. We are going to assume it as a equal to. Okay. Let me assign it is equals to, or if at all you require, you can mention greater than itself, not to change. For if you people it is confusing, you can mention greater than. Okay, let me modify it, guys. So for your better understanding, let me keep it as such. So p greater until my p greater, when your p greater than n, it is going to break it off. So we have calculated p value is still these many times your p is going to execute. I have substituted here and followed by, whenever I'm expanding this one, what happen? Your k square is a higher degree of polynomial, so k square will be taken. Your k square greater than your n value is taken here. So if I'm bringing this particular k square here, let me put the symbol itself, guys. Now it will be easy for you to understand. So when I'm bringing this k square here, it will become square root of n. So what is the time complexity calculated here? That is nothing but your order of square root of n. Is this clear now? Okay, fine. And next is, if at all, we are taken this scenario, right, where it is, I'll take this scenario, I'll take the same scenario. Instead of addition, if I have multiplication. Guys, these are important points, guys. If at all required, I'll give you overall scenario at the end. I will give you overall condition, what will come for each and everything at the end. Instead of addition, if I give multiplication. If I give multiplication, how will we calculate it? This is the other doubt we people might be having. Okay, now we'll see to it. So, okay, I'll give some comparison study for you people. Just a minute. We'll have these two programs, ma. Here, I'll have this one. And let me have one more scenario where we are supposed to do addition of it. Okay. Okay, fine. For this one, look at here. For this one, what we people will be doing? We'll be multiplying a I value. Initially, I value is 1. The I value will be multiplied in this manner: 1 into 2 into 2 into 2. Will be keep on multiplying till n times, right? Will be keep on multiplying n times. This is how this particular loop is going to execute. Coming to this loop. In this loop, you can notice that your I will be keep on incremental. 1 plus 1 plus 1 plus 1 till certain number of times it will be executed, which is nothing but till n times it is going to be executed. Clear? Till n times it's going to be executed. So how this equation is going to be done? So you can notice that here how many time it is going to be executed here till k is equals to n. Here as your value of k, let us assume some k value here. Till here k value is equals to n, this particular loop will be executed till your k value equals to n. See here, in order to make it difference, I have mentioned k here, nothing variation here, guys. Till k value equals to 1, this loop will be executed. Look at this one. This is the squares of it, right? Until here 2 power of k equals to your n value, this loop will be executed. Is it clear? This loop will be, just for comparison study, I kept these two loop aside, guys. Look at here very carefully. Here, this loop will be executed until my k value equals to n. Let some value k be here. Until my k value equals to n, this loop will be executed, and this loop will be executed until 2 power k equals to n. Okay, until 2 power k equals to n. So if at all this is the expression, how can we solve this one? So for this, how will we solve? So for this, what we have mentioned, the order we have mentioned is order of big O of n is the notation which we are given here. For this, your k value is this one, and we people are supposed to find this value. So if some values are down here, if the value is like this, how can we bring it here? If the expression is like this, we can convert where k value equals to log 2, base 2. Log base 2. This is a base 2, guys. Just imagine log base 2 of n. Let me write here base 2 here. Base 2. Where this particular 2 can be bought here just by mentioning log of it. Log base 2 of n. Clear with it? Just I'm bringing this power down to find my k value. How many times this loop will be executed? Okay, if at all it's a multiplication, I'll be having a notation order of log 2 base log 2 of n. I'll be having order of log 2 should be a down, guys. I doesn't know how to bring to sub in notepad is not possible. Log 2 followed by n. This 2 should be in a suffix. Just remind this one. It's not here, but it's a suffix of it. Whenever it is an addition, I'm having order of n. Whenever it is a multiplication, I'll have order of log 2n. This is the calculation part whenever you have multiplication. Since I'm going to have 2 power k times, I'm going to multiply it. Is this clear? Come on. Okay. Okay, guys. And next one, guys. The reason I'm giving each and every example is whenever we people are speaking about time complexity, different notation are there. You people should cover about all the notation. That is the reason I'm giving example for each and every notation. So let me write and show you what are the notations. Yes.
Ma'am, one thing, ma'am, you are giving only the equations. You will do in Python means we can understand, I think.
I didn't use any
You're
programming
saying,
language. Just for loop I mentioned. Just for analyzing the loop.
okay.
I didn't write any programming language. Just for loop alone I given as a general format.
Okay, okay.
Okay, I didn't stick on to any programming language here. Just we are calculating how much time the loop is executed. That's it. Here, if at all you want, you can take a range value. If you want to convert the same program to for loop, what you'll do? You'll take a range. That's it. No variation is there for I in range. For I in range of 1, n plus 1 will be taken as your range. And default step value will be 1. Okay, just I didn't use any programming language, guys. Algorithm is completely about a general scenario, how to analyze the looping concept. Here, this we are going to see with analysis only. In a forthcoming session, we'll stick on to programming language. So far it is general one. Okay, fine. Guys, till this are we clear? Shall I proceed? Okay, before going on next one, I want to let you know why we are seeing these my notation. Why should I know this one? You should have some reason behind it, right? Let me show you what are the different notation available. So we are having 1, which is the lower bound scenario. And next is log n. And next is square root of n. And we are having n. Guys, these are the different notation which we are having. Okay, n log n and n square, then n cube, like this n power 4, n power 5, such a way you are having, and followed by 2 power n, 3 power n. In this manner it goes to n power n. Guys, in this manner we are having lot of notations are there. So only for a familiarity, I'm showing few examples. So you should know how to calculate the notation. It can be of order of n, it can be of order of n square root of n, or it can be of n square. Okay. Okay, n square is the uppermost bound, or n log n. It can be of any notation. So just we are seeing how to calculate this notation and what is the reason behind it. Shall we go further? Is this clear till this? Is that difficult to understand, Ma? Or is that easy? Come on, reply me. Analyzing tool is very much important. What happened? Everyone is quiet. Somewhat difficult. Okay, today I'll complete this one. Once you find time, or whenever you find doubt, you can go through it either by tomorrow's session or in a group. You can ping me, guys. I'll give you whatever the clarification you want. Okay, after this session, whenever you find time, just go through all those things. Wherever you're getting stuck, just immediately you can ping me in the group. I'll respond to your doubt, or just wait for tomorrow's session. By tomorrow morning, once you are beginning, just go through. I'll share this content to you people. Just go through it once. These are very much important concepts. Okay. The reason is once you are seeing the program, first you should be able to calculate the complexity of it. So these are the lower complexity. This is the starting complexity and this is the higher complexity, which is keep on going. Okay. Okay, ma. The next scenario, let me take, if at all the scenario is given like this. Let me take this for look. Instead of typing, let me take this one. It will come, it will say. Just a Okay, next here, I value is n. Here, let me change the condition where my I value greater than or equals to n and followed by I equals to I by 2. If this is the scenario given, how can I calculate it? Here, I'm going to perform division operation. Here, I by 2, not 1 by 2, I by 2. Here, I'm performing division operation, guys, not multiplication or addition. Okay. Here, let us assume what you're going to do it. Assume the condition here. Whenever your I value is less than 1, your loop is going to break. So how many times this particular statement will be executed? Okay, it will execute. Just a minute, guys. We'll see to it how many times it will execute. Something, I mean, something. Just a minute. Give me a second. Guys, let me change the scenario. Something is missing. I'll change the scenario. I by 2. Okay, fine. That's fine. Fine. Okay, guys, listen. So let us assume this scenario where we are going to take my I value from n and I'm going to go to greater than or equals to 1. For each and every iteration, what I'm going to do is I'm going to divide my I value by 2. So whenever my I value is less than 1, it's going to break it off. This is the condition. Okay. Now we'll trace this one. At the first iteration, what is the I value? That is nothing but n. N divided by 2 will happen. At the second iteration, n divided by 2 square. 2 square in this is already the n will be divided by 2. Again, when I am trying to divide by n, what happened? The second iteration, n will be divided by 2 square. Guys, just I didn't reduce the value. Just I'm giving as initial first step n divided by n. And at the second step, n divided by 2 square. And the third step, n will be divided by 2 cube. Guys, are you following this one? Can you able to get this one, ma? Come on, answer me.
Yes, ma'am.
Okay. So in this way, I'll be keep on going. So until my n divided by 2 power k, this iteration will be done. So how to calculate it? How can I calculate my n value? So this is my I value. This is my I loop. The I is going to execute till my n divided by 2 power k times. So how can I calculate it? The calculation is done by n is equals to, this is the I value. So as per the notation, I less than 1. So I value calculated is n divided by 2 power of k less than 1. So convert this as a equation. So a n will be here, n less than 2 power k, where this 2 power k will be brought here, 2 power of k. Okay, since the power notation is not easy to mention in notepad, just I mentioned cap symbol here. So instead of less than, you can assume equal. So just for assignment of it, we can convert this expression by assuming that n equals to 2 power of k. So I want my n value, where the n value is taken as k is equals to, when I bring this particular 2 here, it will become as log 2 log base 2 of n. Guys, just I'm calculating the n value, log base 2 of n. Just I'm bringing this particular value to, okay, to this side. So I'm separating and I'm bringing here, I'm supposed to take a log. So log 2 has to be taken. So log 2 of n is the value of that time taken here. So this is given by using a big O notation. Big O notation is given by using, guys, I do understand this little dry subject only. Just try to understand. It is very simple. Like this, lot of examples are there, guys. Okay, now let me give a very simple
Ma'am,
example. Yes.
here n equals to 2 power k now, ma'am.
Yeah, n is equals
N
to 2
value,
power k. Yeah.
then n value can we take as 2 power k, ma'am? Then why you converted it into log?
Yeah, I'm supposed to find the k value, not n value. I'm supposed to find how many times, k times the value, how many times the loop has been executed. What is the value
So
of k?
we have to find the value of n now, ma'am.
Not value of n. How many times the loop executed is considered as k here. The n, I'm considering the terminology for the iteration. Instead of n, you can use some other variable also. Since I used n, it might be confusing for you people, I guess. The division, whatever you're performing, I can taken as n by 2.
Okay, ma'am.
Okay. So let me give one more simple example, guys. So if at all two for loop is occurring in a same line, for example, let me consider this example. This example which we did. We have two separate for loop like this. In a same program, I'm having two for loop. So now what is the order of this one? Can you people calculate it? Yeah, you want while loop. Okay, we can take with while loop. This is about to complete. We'll take while loop. What is the order of this one? N, right? Order of this is n. So we are having two separate order of n. So we'll have added together, n plus n will get 2n as your answer. You will get 2n as answer. So a 2 is removed. So your order will be order of n. Is that clear? If you have two individual loops, it is not dependent on each other, then you'll be having n squared as then you'll have separate two n's. Overall will take only order of n as your output. Is this clear so far? Come on, answer me. You can go ahead with while loop.
Ma'am,
Yes?
in this loop, it will take n plus 1, n plus n or n into n.
This one, plus plus, n plus n. This is separate and this is separate, right? Both are separate in the same program. So it will take n plus n.
If it is inside, it will take n into
n
n, ma'am.
into n. Yes.
Okay, ma'am.
Okay. Now still few more programs are there, guys. Since time is not sufficient, I'll give you the overall notation for each and every loop. Then we can go ahead with while loop now. Okay. As a overall, let me write few statements here. From the morning, we are seeing certain condition. Let me write. If at all your I value is 0 and I value is incrementing in this way, we know that your order is order of n. If at all your I value is 0 and you're executing 2 step for each values, what is the order we got? Either 2 step or 20 step, what could be the order again? We'll get n by 2, where n by 2 is given with the notation order of n again. Guys, got this one? This one we have seen. Just I'm giving overall view of it again. Okay. If at all I'm starting with n and I'm going till 1 and I'm decrementing for each and every step. Even now, my order will be only of order of 1. So order of n, sorry, order of n. Clear? Whatever the step you take. Apart from this, what else we are seeing? I guess we are seeing with multiplication. So if at all I'm going to multiply by 2 for each and every step, if at all I'm going to multiply by 2, then we got order of log base 2. Okay, this is base 2. Base 2 of n. This could be the scenario. If at all you're going to multiply by 3, you'll have base 3 of n. Is that clear, guys? Okay. Now, this is all about your addition, incrementation, decrementation, and this is all about your multiplication. Apart from this, what else you are seeing? If at all you're going to perform division operation, I is equals to I divided by 2, you'll be getting log 2 base n. Is this clear? Guys, different ways there, just are given for most repeated one. Is this clear so far? Shall we go for this while loop, ma? Come on. In next section.
Ma'am,
What
for
happened? Yes.
I divided by 2,
Hmm. For I divided by 2.
order is same as I multiplied by 2, ma'am.
Yeah, same order. It's not going to vary. This is what I mentioned here. You can notice we are calculated here, I guess. So either division or multiplication is going to give you same order. Clear with this one? Come on.
Clear, ma'am.
Okay. Okay, can we see one or two problems in while loop? Just one or two alone. I guess it's 10:30. Just one or two problems by today. Is that okay? Say yes, no, something. Nagaraju wants the next class. Okay. Yes.
Next class, ma'am.
Next class.
Tomorrow we can come.
Tomorrow we can see. Okay,
Okay.
guys, by tomorrow we can continue with while loop analysis, and we can have omega notation. Then lot of things are left over. Omega notation followed by recursion. Okay, guys. Okay, thank you. I'll share this content in the group, guys. Without fail, just try to work it out. This is important. Okay, thank you, guys.
Okay, ma'am. Thank you.